This is a short video on polynomials and polynomial operations. We talked about monomials, mono meaning one, last class. Now we're going to talk about polynomials, poly meaning multi. So really all a polynomial is a sum of one or more monomials. And I say one or more because technically a monomial is a polynomial. But we would never call it a polynomial because it's just one. It has a more specific term, and that's a monomial. So we're going to look at a sum or a difference, because a difference can be written as a sum. So we're just going to talk about sums of polynomials. Sums of monomials, which we will call polynomials. So a polynomial is made up of a bunch of monomials, and each one of those monomials is called a term. So I'm not going to refer to them as monomials anymore. I'm going to refer to them as terms. So when I say this polynomial is made up of 3 terms, you know what I'm talking about. The degree of a polynomial is the monomial or term, what I'm going to refer to as term, with the highest degree. So we're looking at something, if we have something along the lines of x squared plus 2x plus 1. The degree of this polynomial would be 2, because x squared is the monomial with the highest degree. 2 is the highest degree. So that's why we're going to call that degree of this polynomial 2. Now let's look at some operations with polynomials, and these are fairly quick, fairly easy. You may have seen these before. Addition and subtraction is really easy. Multiplying and dividing is a little more complicated. Addition and subtraction, we're just going to basically treat this like these parentheses aren't even here. When you're adding, it doesn't matter which order they come in. Remember, 2 plus 3 is the same as 3 plus 2. So it doesn't matter which way I have these. I'm just going to do 2a plus 3b plus 8a minus 5b. And now I'm going to collect like terms. So my a and my a go together, so 2 plus 8 is 10. And then my 3 and my 5 go together, so that's 3 and negative 5, so that's negative 2b. And that's it. We're just adding 2 binomials here. This is a binomial because it has 2 terms. This is a binomial because it has 2 terms. So we're adding those together. When you're adding together, again, order doesn't matter. Now, example 2, we're subtracting. In this case, subtraction does matter because, remember, 1 minus 4 is not the same as 4 minus 1. So order does matter here. So when we look at this, I've got my first polynomial, and this has another specific name. This is called a trinomial because it's 1, 2, 3 terms. So we have binomial with 2 terms, trinomial with 3 terms, and then after that we just call them polynomials. Okay, so we have monomial, binomial, trinomial, mono, bi, and tri, meaning 1, 2, and 3. And because they're used so often, they're so common, we give them special names. But everything after that is just a polynomial. So we have our first trinomial minus the other trinomial. It does matter what order these come in. And you have to be careful when you get rid of the parentheses here. So x squared minus 4x plus 3, I can just get rid of those parentheses, because it's exactly like it says. However, you have to be careful here because this negative is going to get distributed to each one of these terms. So think of it as like a -1 times each one of those terms. So that's actually going to give us a negative 4x squared minus 3x, and then negative times a negative is positive, so plus 5. This is where you have to be careful and make sure you distribute that negative through those parentheses. So now I'm just collecting like terms. I've got x squared and negative 4x squared, so that's negative 3x squared. I've got negative 4x and negative 3x, so that's negative 7x. And I've got 3 and 5, so that's plus 8. So when I have one trinomial minus another, I get this negative 3x squared minus 7x plus 8. Addition and subtraction, not that bad. Next, we're moving on to multiplying. And multiplying is a little bit different. We're still going to apply some of the properties that we've seen before, and that main property is the distributive property. So what that means is we're going to take this 2x here, this whole 2x, and we're going to multiply it by the 3y and multiply it by the positive 9. So when I multiply that, I get 2x times 3y, so that's 6xy plus 18x. And that's it. There's nothing I can do with that. That's it. So next problem is just a monomial, in this case, 2xy. And we're multiplying it by a trinomial. But same rules apply. We're still taking it times the first term, times the second term, and times the third term. Still distributing. So we do 2xy times xy squared. So that's 2. X times x is x squared. Y times y squared is y cubed. Plus 2xy times 2x. So 2 times 2 is 4. X times x is x squared. And y times nothing, or not nothing, but there's nothing else to multiply there, so it's just y times 1. So that's y. And lastly, I get 2xy times 3y cubed. So 2 times 3 is 6. There are no x's, so it's just we're gonna keep our x. And y times y cubed is y to the 4th. And that's it. Now, if there are any like terms, we combine those, but there's not. We've got x squares and y cubes, x squares and y, x and y to the 4th. Remember, each one of these is a term. Term, term. Those are all monomials because each one of these x's and y's are multiplied together. Next example is where we learn a little bit of an extension of the distributive property. And this is something you've probably heard of before, and that is foiling. Foil. And this actually comes from the distributive property, because the distributive property says you take the number, whatever, in this case x, and you multiply it by every number in the other quantity. So I'm going to take x, and I'm going to multiply it times x and times 3. And I also have to take the 6 and multiply it by x and multiply it by 3. So basically, FOIL is just a special mnemonic to help you remember to multiply everything by everything once. That's what it boils down to. So when we multiply this, we use the FOIL. First, outside, inside, last. So I'm going to do the first term times the first term. So that gives me x times x, so that's x squared. And then I do the outside terms, which is x times 3. So that's 3x. And then the inside terms, 6 times x, so 6x. And the last terms, 6 times 3, 18. When I combine like terms, I get x squared plus 9x plus 18. Now I want you to try to apply this same method, but this time multiplying a binomial and a trinomial, and we'll talk about this one in class.